Hello and welcome back to another video. If you're new here, welcome. I'm Jessie. These are my notes. So let's get started with this important topic, which is integration using reverse chain rule. So this is like usually the next rule, integration rule you learn after just the basic power one, where you increase the power by 1, reduce it by 1. And the reason why it's called reverse chain rule is because it's awfully similar to chain rule, the derivative form. I cannot explain reverse chain rule without first talking about normal chain rule. So let's say that if I have something like 2x plus 1 to the power of 5. Okay, now that's the giveaway for when to use chain rule, right? Whenever you have an inner function and then you have an outer function. So that's going to be the same thing you look for when you're integrating, is you look for something that is also in this form. Now, if I wanted to differentiate this, what you're doing is you're essentially performing power rule. So you're bringing the power down to the front, you're reducing it by 1, but what you're doing as an extra added step is you're also timesing the whole thing by the derivative of the inner function, which in this case is going to be 2. And then all you need to do is just combine the numbers and then rewrite your form. Lovely. Now, if I wanted to integrate the same thing using reverse chain rule, guess what? Same thing. It's literally the same thing, except it's the opposite sign. So, sorry, not opposite sign, it's the opposite process. So what we're going to do is we're going to perform the power rule, where instead of decreasing the power by 1, we increase it by 1. You're going to divide it by that new power. Now, you're also going to take the derivative of the inside, which is 2, but instead of timesing by 2, you're going to divide it by 2, which is the same thing as timesing the denominator by 2. And then now you're going to end up with 2x plus 1 to the power of 6 all over 12. Okay, so let's just go straight into this example then. I want to find the integral of 2x plus 3 to the power of 4 dx. So first thing we want to do is increase the power by 1, divided by that new power, and then you want to times the denominator by the derivative of this guy, which is going to be 2, very similar to the other example we did. So this is then going to give you 2x plus 3 to the power of 5 over 10 plus c, because it's an indefinite integral. Yay, indefinite integrals are the best because you don't have to chuck stuff in the calculator. Next, question 2. Find the integral of 3 on 7, 1 minus 5x all squared with respect to x. So first thing that I want to do is I want to make sure that this is in a form that is actually integratable. And whenever x is on the bottom, chuck that guy back up at the top. What is he doing? So I'm going to rewrite this as 3 on 7. So I'm just going to write it as a constant, like that's like next to the bracket. 1 minus 5x to the power of negative 2 dx. Okay, now that it's in this form, let's go ahead and perform reverse chain rule on this guy. So we're going to end up with 3 on 7, 1 minus 5x. If you increase that by 1, you get negative 1. Divided by that new power, and then you also need to divide it by the derivative of the inner function. Now the derivative here, do you guys see what it is? Negative 5, right? We're going to divide it by negative 5. So now we get times negative 5 there. Now the last thing we want to do, just clean this up a little bit. The only constant at the top is 3. Now the constant on the bottom is going to be the product of all of these guys. Now, negative 1 times negative 5 is just positive 5, and then 5 times 7 is just 35. So you're going to get 3 on 35, and then I could write this as 1 minus 5x to the power of negative 1, but I'm just going to write it with it in the denominator like this. Beautiful, plus c. Can't forget those plus c's. Great. Next one, question 3. Find the integral of that. Okay. Now, if I want to integrate this, 2 things wrong with it. First, there's a square root. And then the next thing is that it is on the denominator. So we're going to be using the index laws. So the first index law is the fractional one, which says that if you have a to the power of m on n, you can also rewrite that as a surd. Whatever is on the top goes on the inside, whatever is on the bottom goes on the outside. I'm also going to be using the negative index law, which says that if you have a negative power, you can write it as 1 over a to the power of m. Okay, so if I were to do this, let's apply both of these index laws on this guy. Let's do it step by step so we know what's going on. So I'm going to first change this to a change it to a power, yep, a fractional power. So right now, 2x plus 4 is technically to the power of 1. So that's going to be 1 over here. It's a square root, so it's a half. The next thing we want to do is bring that to the top. So we're going to get the integral of 2x plus 4 to the power of negative a half dx. And then now it is ready and primed to be integrated. So now we get 2x plus 4. If I increase this power by 1, don't touch the calculator. You want to get used to fractions. We're not going to add 1, I'm going to add 2 on 2. So whatever the denominator is, I add that. All right, and then now that's more clear. The new numerator is going to be 1, positive 1, and then the denominator stays as a half. Now we're going to divide it by that new power. So if I ever have a fraction, I don't want to divide it by another fraction because then you have fractions and fractions, which suck. What you're going to do instead is you're just going to swap it around. So if 1 is normally at the top, it's going to go on the bottom. If 2 is normally on the bottom, it's going to go on the top. Okay. And then the last thing you need to do is you need to take the derivative of the inside, which is 2, and instead of timesing it by 2, you're going to divide it by 2. Lovely. And when you look at this, do you guys see? These 2's are going to cancel. Hurrah! So now we just end up with the square root of 2x plus 4 plus c. Amazing. All right, let's do question 4. It says, find the integral of 8x bracket 3x squared plus 4 all squared with respect to x. Okay, so you might notice, ooh, this looks interesting. I'm going to use product rule because we have two things times each other. And to that, I would say, wrong. There is no such thing as product rule or quotient rule in integration. We leave that in differentiating only. So how are we going to do this? Well, this is still going to be reverse chain rule. It's just that in the other examples we went through, so let me just quickly show you, in this one over here, and in this one over here, and in this one over here, did you notice that all of your inner functions were linear? Linear meaning the highest power in x is the power of 1. This one's got 2x plus 3, that's got 1 minus 5x, this has got 2x plus 4. When you have a non-linear inner function, whether it be a squared, a cubic, even like a trig, when it's non-linear, you're always going to have some guy on the outside, which is this 8x, which I like to call the spectator. He's a spectator because he's just chilling. He's not doing anything. He's just looking. All right, so that's our little spectator guy. But you do the exact same steps. So when you integrate this, spectator just coming for the ride, you're going to increase this power by 1, divide it by that new power, and you're also going to times the denominator by the derivative of the inner function, which happens to be 6x. Okay. And what's going to happen is the x's should cancel out. So that's why the spectator, he's chilling, because eventually he's going to go away. So now we're just left with 8 divided by 18. And then that will simplify to be 4 over 9. Okay, and lovely. Now I should also mention that if you ever have a non-linear inner function, you have to have a spectator. You are not allowed to integrate something that looks like this. This, in the advanced course, this is actually not integratable because there is no spectator with the x on the outside. And just also another thing, how you know it's going to be reverse chain rule if you have a nonlinear function is if something that resembles the derivative is on the outside. So in this example here, the derivative is 6x, right? The derivative of 3x squared is 6x. And you have something that resembles that. It's 1 power less than the squared. It's just 8x, x to the power of 1. Okay, so this here is actually not integratable. What you would actually have to do is you'd have to expand this entire thing, which is going to have like many terms, like 10 terms, and then good luck. Good luck not making a mistake there. Okay, beautiful. Next, question 5. Find the integral of 3x divided by the square root of x squared plus 2 dx. Okay, now when you look at this fraction, you might also think quotient rule, and to which that I say, once again, no quotient rule in integration. What I'm going to do is I'm going to actually bring this square root up to the top as a negative power. So let's do this in steps. First, I'm going to rewrite x squared plus 2 as to the power of a half. And then if I bring that to the top, we get 3x bracket x squared plus 2 to the power of negative a half. Lovely. And then now this is still going to be reverse chain rule because we have that inner function and then the outer function power. And then you notice how we have a nonlinear inner function and then you have something that resembles its derivative on the outside. So that guy there, he's our little spectator fellow. All right, so what we're going to do is we're going to integrate this, leave the spectator aside. We're going to increase that power by 1. If you add 2 over 2, you just get a half. And then you're going to divide it by that new power. So the 1 goes on the bottom, 2 goes on the top. And then you're also going to times the denominator by the derivative of this guy, which is going to be 2x. Now, always, the spectator, the x value in the spectator has to go away. So this x and this x cancels. And what's really nice is that this 2 and this 2 also cancel. So now we are just simply left with 3 times x squared plus 2 to the power of a half. So that's going to be 3 square root of x squared plus 2. And then it's all over 1, so we just leave it as such. Cool. And the lucky last one for today, we want to integrate x plus 4 times x squared plus 8x plus 2 all squared dx. Now, you might be thinking, this one looks more confusing. Well, it's different because we have a larger inner function. It's got 3 terms. And our spectator has 2 terms, but trust me, it's the same thing, guys. Rinse and repeat. So that x plus 4 is our little spectator. So we're going to write our spectator there. We're going to increase this power by 1, which is 3, divided by the new power, and we're also going to times it by the derivative of the inside, which is going to give us 2x plus 8, and chuck that guy in brackets. Now you might be thinking, well, this sucks because my spectators, they don't cancel out, they're not the same. But have a look more closely. 2x plus 8 can actually be factorized into 2 bracket x plus 4. And you know what's awesome is that x plus 4 cancels. So now all we're left with is x squared plus 8x plus 2 all cubed all over 6 plus c. Yes, and that is it, guys. I hope that was a helpful video. Please comment down below if there is any other topic you'd like me to go through. I would love to help you all. I will see you in the next video. Bye-bye.